Okay, this week we're going to look at some properties of real numbers, and you're going to be killing it this week. So after this video, you'll be able to classify and compare real numbers. So really quick, here's some definitions for you. First one is this: a set. A set is just a well-defined collection of objects. Obviously in math, we'd be talking about numbers. So for example, a set would be just a set of 9th grade students. That's a big set of people at Lake Roosevelt. A subset is a set of elements inside the set. So if the 9th grade students is the set, then a subset could be 14-year-olds that are 9th grade students. Pretty basic. So I want to show you this example because it will get you ready for what I really want to show you. So in this picture, you can see Mr. Burns' class, you are a member of that set. That's a set of people in my math class. Now that set is also in a larger set, and that larger set is all the students at Lake Roosevelt High School. So Mr. Burns' class is a subset of the Lake Roosevelt High School student body. And that is in a bigger set, and that would be the Grand Coulee Dam School District. So all the students at Lake Roosevelt are part of the Grand Coulee Dam School District, and all the students of Mr. Burns' class are a part of Lake Roosevelt High School. And then finally, you could make a larger set, like all the schools in Washington State. So there might be a student in my class. Here you are. You are a member of the set of my class, which automatically makes you a member of the set of students at Lake Roosevelt High School, which automatically makes you a member of the set at Grand Coulee Dam School District, and automatically makes you a set of students in Washington State. Now you might have a friend who goes to school in Kennewick. Is that person in my class? No. Are they at Lake Roosevelt? No. Are they at Grand Coulee Dam? No. Are they in the Washington State schools? Yes. So they're a member of the bigger set, but they're not a member of the smaller subsets. You might know somebody also that is a kindergartner. Are they in my class? No. Are they at the high school? No. Are they in the Grand Coulee Dam School District? Yes. So they're a member of this set and this set, but not of the first two. So let's take a look at what we really want to talk about, and that's real numbers. This big red box represents all real numbers, and for you, that just means any number you can think of in the whole wide world that you know of, because you don't know about imaginary numbers yet. There's a set of numbers in the real numbers that are called natural numbers. And natural numbers are just the numbers that you count with. So 1, 2, 3, and so on, and it goes on forever. And those 3 dots represent the fact that it goes on forever. You don't count with the number 0. You don't count with negative numbers, so the natural numbers just contains 1, 2, 3, 4, 5, 6, and so on. You also don't normally count with decimals or fractions. Okay, the next set is a lot like the natural numbers. It's called the whole numbers, and the whole numbers are all the natural numbers plus one more number, and that number is 0. 0, 1, 2, 3, and so on. So the whole numbers are all the numbers, 0, 1, 2, 3. They contain all the natural numbers plus that one extra number. Okay, the next set of numbers includes all the whole numbers, 0, 1, 2, 3, and their opposites, and those numbers are called integers. So integers include all the whole numbers, 0, 1, 2, 3, and so on, but they also include all the negatives, -1, -2, and so on in the opposite direction. So if a number is an integer, it's also a whole number, it's also a natural number. All right, the next set of numbers in the real numbers, they're called rational numbers. And rational numbers are just numbers that can be written as a fraction of integers. So 1/2 is a rational number. A rational number, like 1/2, isn't an integer because it's not whole and it's not natural. Okay, another way, or another rational number is 0.3, because 0.3 could be written as 3/10, and that's a fraction of integers. Or 0.3 repeating, because that could be written like 1/3. Or -7, because -7 could be written as a fraction like this. So if a number is rational, does that mean it's also an integer? Well, here's 1/2. 1/2 is a rational number. Is it an integer? No. Is it a whole number? No. Is it a natural number? No. But if I give you a number like 7, and you want to check to see what kind of number it is, you'd start first with the natural numbers and ask yourself, is 7 a natural number? Is that a number you can count with? Yes. So it is a natural number, which makes it a whole number, which makes it an integer, which makes it a rational number. Okay, the last set of numbers are neither rational, integer, whole, or natural, and they're called the irrational numbers. Irrational numbers can't be written as a fraction. So those are numbers that go on forever without a pattern like pi or square root of 2. Those are irrational numbers. So that's pretty much it for the concept. Here's what kind of problems you might see in your assignment this week. You'll be asked questions like this. Which set do the numbers belong? So here's the number 10. What kind of number is 10? So to answer the question, you go back to this table and you ask yourself, is it a natural number? Is 10 a natural number? 10 is a natural number, so I'm going to write n for natural. Well, if it's a natural number, then it's automatically a whole number, automatically an integer, automatically rational. So the answer to 10 is natural, whole, integer, and rational. Okay, look at the next one, -2.346. What kind of number is that? Is it a natural number? Do you count with that? Nope, it's not. Is it a whole number? Is it one of the natural or 0? Nope, it's not. Is it an integer? Well, it's negative, but these numbers are negative wholes, like -2 and -1, not a decimal. So it's not an integer. So the only answer for this one is that it's a rational number. So some numbers can be a member of several sets. Some might just be a member of one set. Either way, if it's a rational number, it cannot be an irrational number. It has to be either irrational or rational. So look at the last one, square root of 5. Square root of 5 is not natural, whole, integer, or rational, so it has to be irrational. Okay, you might also see a problem that looks like this, where you have several numbers and you just have to check off the box that matches. So for this first number, 23, is 23 a natural number? Is it a counting number? It is. Is it a whole number? It is. Integer? Yes. Rational? Yes. So if it's rational, it can't be irrational, so you can't check that one. Okay, I want you to try the last two, and then that will be the end of the video. Alright, good job. -0.75 isn't natural, it isn't whole, it isn't an integer, it's just rational. And the last one, square root of 5, not natural, not whole, not integer, not rational, it's irrational. Great job. Now you can go on and do the assignment that goes with this video.